Alright, hi guys, it's Miss G. This is our first instructional video for the school year. This is what most of our lessons are going to look like going forward. There'll be a video from me. After we do open house on the 9th, I believe, one of those days in early September, you guys will be able to come to the school and pick up materials that you guys need for your classes. And so you will eventually have a notebook that looks just like this. But until then, I just need you to follow along and take notes in just a regular notebook or on any blank piece of paper. So go ahead and get that now. You can pause the video if you don't have one, and then just take notes and follow along with me. And then I promise we'll get you guys a workbook as soon as possible, and then you won't have to, draw the pictures or anything after that. All right, so we're going to start with the first problem. We are going to talk about segments today, okay? So segments are like a snapshot of a line. So right here, we're looking at a section of a number line that goes from -3 to 4. So it says, refer to the figure shown. How can you find the length of AC? So the length of AC is this distance. Oops, need a pencil. Let's do liquid green. The distance from here to here. The good news is that it's exactly as easy as you think it's going to be. Just the most important thing for you guys to remember, you want to count the spaces, not the lines, okay? So if I wanted to know the length, I would say 1, 2, 3, 4, okay? Don't count the lines because then that would go 1, 2, 3, 4, 5, and that's not true. Count the spaces. So 1, 2, 3, 4. So you would say the length of segment AC is 4. There's going to be in your notebooks, there's going to be a notes column on the left that you will be able to jot down some notes on. But for now, your notes don't look like that. So just know that it exists, but you don't have to worry about it right now. All right, so refer to the figure shown. What is JK? What is KM? So now we're looking at a number line where we don't have spaces or lines to count. Okay, so we want to know what's the distance between J and K, or what's the distance between K and M. What you're going to do is you're going to find the absolute value. So absolute value. That means these straight bars right here that tell us the positive distance from that number to 0. So absolute value is always positive. And we're going to find the absolute value of the difference. And then what operation does difference mean? Multiplication, addition, subtraction, division? It's going to be subtraction. So that was a lot of words, but I promise the work is really easy. So if I want to know the distance from J to K, I'm just going to do the absolute value of 12 minus 5. And so the reason that we do absolute value is because there's no order. So 12 minus 5 is 7. The absolute value is 7. But you could have also done 5 minus 12. And 5 minus 12 is also just 7. So that's what the absolute value is for. It doesn't matter which direction you go. So JK is 7 units long. So go ahead and try KM. You can pause the video if you want to. Try it and then unpause it and see if you did it the same. You've got 12 to 27. What's that distance? So you can do 27 minus 12. Or you can do 12 minus 27. And either way, you are going to get 15. Not too bad for our first lesson, or first video lesson. All right, number 3 is where it gets a little bit stepped up, but the good news is that this is just all the skills you guys have already learned in Algebra 1. So it says that JK and L are collinear. Collinear means they're on the same line. And remember, guys, you have the power with this video to pause, go back, rewind. I know I'm not the slowest talker. In fact, I know I'm a pretty fast talker. So if you're still, drawing the picture or something, pause the video, and then, draw it and then take the notes with it. So yeah, your call. Use the video to the best, to your best ability to serve you. So JK and L are collinear, which means they're on the same line. If JL is 25, what is the variable n. So if the distance from here to here is 25, then what is the variable n? Okay, so this is what we call the segment addition postulate. You guys can, obviously if you're using a regular notebook, you can take this note wherever you want. I'm going to use this note column just so I get in the habit of it. This is the segment addition postulate. All this means is that if you have 3 points, A, B, C, that the chunk AB plus the chunk BC equals the whole line AC. Okay? So that means that if you knew that the distance from A to B was 10 and the distance from B to C was 15, then the whole line AC would be 25 units long. Okay? So, using that postulate, I'm going to use the letters that we have. So anytime you have 3 letters, we have, I wrote over it, but we have J, K, and L, I'm going to write out that postulate. So I know that the first segment, JK, plus the second half of it, KL, has to equal the whole segment, JL. And I find that it's really helpful to write that out because now I know exactly where to plug everything in. Okay? So I know that the segment JK is 3n. So this time I'm going to write 3n plus the segment KL, which is 5n minus 7. You can put that in parentheses if you want to. Equals JL. And I know that the whole thing, JL, is 25. And so now this is where it becomes Algebra 1 again. So the geometry is over. This is officially an Algebra 1 problem. We're just going to combine like terms and solve. So I have a 3n and a 5n. And then I've got a negative 7, so that doesn't combine with anything. So if I have 3 n's and I add 5 more, then I have 8 n's. I still have that minus 7. And then I have a 25. Okay? So this should be home base. This should be our number 1 favorite problem. This is just like that 2-step Algebra 1 problem. When we get to this point, we're like, yes, this is awesome. You could take it to the end and rock it out. Once you get your problem looking like this is your home. You should love this. So what I'm going to do is I'm going to undo the operation. So if I'm subtracting 7, to undo that, to make that 7 go away, I'm going to add 7. Remember, whatever I do to one side of the equal sign, I have to do to the other. So now I have 8n left equals 32. And anytime a number is directly next to a variable, that means they're being multiplied. So if they're ever just sitting next to each other, that means they're being multiplied. To undo multiplication, I'm going to divide. And n equals 4. So the good news is that this work helps us do part B. So it says, what is n? We know that n equals 4. And now it says, what is jk and what is kl? Well, we're just going to plug in that 4. So if n is 4, 3n is actually 3 times 4, which is 12. And then 5n minus 7 is really 5 times 4 minus 7. And 5 times 4 is 20. 20 minus 7 is 13. And then my favorite thing about math, like that other subjects can't always boast, is that you can check right there and see that your work is right. See that you have the right answer. Because does 12 plus 13 equal the whole segment 25? Yes, it totally does. So that's how I know I got the right number. So JK is 12 and KL is 13. All right, now we're going to take a look at some angles, and then we'll almost be done. So, number 4, talks about angles using a protractor. So I like to think of angles as like hands moving on a clock, okay? The angle is measuring the distance that this line has moved, excuse me, from here to here. So as I can see, if this was like a clock hand ticking, this would be 10 degrees, then it moved 20 degrees, then it moved 30 degrees, then it moved 40 degrees, and now it's here. That swoop, that distance traveled in a circular way is what an angle is, and we measure that in degrees. Okay, so the same thing that we talk about for weather, that's also how we measure units of angles, is as a degree. So it says, what is the measure? So whenever we see the little m in an angle sign, that means the measure of angle blah blah blah. So this is the measure of angle AEC. So what does this mean, this AEC? What angle is that? Anytime I see an angle that's labeled with 3 letters, I always play connect the dots. So I literally start at the first letter A, I connect the dots to the next letter E, and then I connect the dots to the last letter C. And so that's how I know what my angle is. I play connect the dots, AEC. So I'm looking for the measure of the angle that has traveled from here to here. And so again, it's gone 10 degrees, 20, 30, 40, 50, 60, 70, 80, 90, 100. And it's right here on this line in between 100 and 110. So halfway between 100 and 110 is going to be 105 degrees. So then what is angle BED? Again, remember, rewind, pause, whatever you want, especially when I erase things like this. If you want to go back and see it, then you can go back and see it. So angle BED, I'm going to play connect the dots. BED. And so I want to know the distance that they've traveled from here to here. So now this one's tricky because it's not going to start at 0, right? It was easy to look at this line because this angle was at 0. So I was measuring the distance from the 0 to the 105 line. Now I'm measuring the distance from an angle that starts at, looks like 46 degrees to an angle that ends at 130 degrees. So if I want to know what that is from 46 to 130, then I'm just going to do 130 minus 46, and then that's going to tell me. So that means the distance that this angle has traveled, it went 10 degrees, 20 more, 30 more, 40 more, 50 more, 60 more, all the way 84 degrees to land at that mark. So angle BED is 84 degrees. That's how many degrees that the arms traveled when they started at 46 to finish at 130. And then lastly, number 6 is kind of just like number 3, but with an angle. So it says if the measure of angle NOP is 31 degrees, so I'm going to play connect the dots, angle NOP is 31 degrees. So whenever I label an angle, I always draw the arrow so I know like where the 31 degrees is. So that arrow, the distance from the NO arm to the PO arm is 31 degrees. And measure of NOQ is 114. So I'll do that. So NOQ is this whole arrow, I want to know the distance from the NO arm to the OQ arm is 114 degrees. What is the measure of angle ROQ? So we are looking for angle ROQ. So there's something interesting that we have to look at right here before we can continue. Right here, if we look at our whole, I'm going to move our stuff for a second. If I take all this off and we look at just our diagram, we can see that there's this little notation right here. There's a line between in this angle and there's a line in that angle. Anytime that angles are marked with the same line inside the angle, that means those angles are congruent. That means those angles are congruent, and we can put that over here. Congruent means equal or the same. So that means that if this angle is 20 degrees, this angle is also 20 degrees. If this angle was 40 degrees, this angle would be 40 degrees. So that means that we don't know what these two angles are, but we know they're going to be the same amount. So I don't know if I can make this go back to the colors that I originally picked, but here we are. All right, so this is my diagram. I like to think of angles as a road trip, okay? So what I mean by that is on our road trip, we know we have to travel 114 miles. It's 114 miles from, think of it like New Circle Road, right? Because New Circle is that circle road. So maybe you live here on New Circle and your friend lives over here, and you've got to go 114 miles around. So what we know is that from here to here is already 31 of those miles. So if I had 114 miles total and I'd already done 31 of those miles, how many miles are left? What would I do to produce that number? Think about it for 5 more seconds. So if I had 114 miles to go and I'd already done 31 of those miles, I would subtract that from my total. That way I would know that I only have 83 miles to go. So that's important because we know that this whole chunk left is 83 miles. If this whole chunk is 83 and this half has to be the same as this half, what would I do? If I had 83 of something that I had to split equally amongst 2 people, what would I do? I would do 83 divided by 2. And that's going to tell me that each angle is going to be 41.5 degrees. So I'm going to erase. Again, you guys can go back. You can add it all up and see that it makes sense. This angle is 31 degrees, the distance from here to here. This is 41.5. And this is 41.5. And when you add those numbers together, that will equal your 114 mile distance from there to there. So angle ROQ is 41.5 degrees. All right, so that's our first lesson. You guys are going to have a quiz in Canvas that's going to help you guys like implement these skills that you just learned. If you have any questions, text me, call me, Canvas message me, email me. Remember, my phone number is 859-903-5430. So call or text if you have questions. But yeah, I hope you guys enjoyed this video. There's going to be many more.